How does one box in your home connect your phone, your laptop, your TV, your fridge to millions of websites worldwide? How do companies connect their many offices securely? The answer is routers, the traffic directors of the internet. Welcome to our CCNA journey. My name is Ali, and in this video, you'll discover exactly what routers do, why they're essential. If you're starting on your networking journey or you're studying for your CCNA exam, we're covering the first topic under the Network Fundamentals module in the exam blueprint. So let's begin. Let's start with the basics. What exactly does a router do? Think of a router as a smart traffic controller directing traffic to destinations all day, every day. Number one, a router does routing. This is a fundamental purpose, connecting different networks and finding the best path for data. Your home network is completely separate from Google's network. Routers connect these different worlds. Routers do network address translation, or NAT. Your ISP gives you one public IP address, but you have 20 devices at home. Your router does the translation between these two addresses. This conserves IP addresses and adds security. Routers do VPN, virtual private networks. They create encrypted tunnels through the internet. If you're working from home, your router creates a secure connection to your office. Routers can filter traffic based on access control lists, or ACLs. You can block traffic from certain locations. You can allow traffic to certain websites or permit certain users while blocking others. Routers can also apply quality of service rules. Quality of service ensures important traffic gets priority. Ever notice Zoom calls work fine while someone's downloading games? That's QoS. Routers can also handle phone calls. Voice over IP converts your voice into data packets. One device, multiple functions. It's why offices don't need multiple phone lines anymore. So what's inside a router that makes the magic happen? As a hardware device or an electronic component, the router has a CPU, the brain that handles all the routing decisions. It has memory, non-volatile RAM to store all the configurations or the settings, flash memory to store the operating system, a read-only memory. This is where the boot instructions and the recovery mode are stored, and it has interfaces where you put the physical connections to networks. Some other features of routers, they can be a DHCP server and automatically assign IP addresses to devices. It has firewall capabilities for basic security protection, port forwarding to direct traffic to internal servers, and failover support where you have backup routers in case the primary one fails. Think of it like a specialized computer built for one thing, moving data very efficiently and very fast. Let's look at some types of routers. You have the home routers that combine multiple devices into one box. Of the router, you have a switch so you can connect multiple devices, a Wi-Fi access point, and you have firewall for basic security. Home routers cost between $50 to, let's say, $300, and they can handle 10 to 50 devices or so. They have a simple web interface so you can manage them. They handle speeds up to, let's say, 1 gigabit per second or even more, and they're perfect for gaming and streaming and work from home. Then you have a small business routers. These cost between, let's say, $500 to $2,000. Something like these ones right here. They're more reliable than home routers. They handle 50 to 200 users, and they have professional features like VPNs and virtual local area networks and higher speeds. And then you have enterprise routers. These have modular designs where you can add features as needed. They handle thousands of connections. You can run dynamic routing protocols where they dynamically find the best path to destinations, and they handle higher speeds. These ones will cost thousands and thousands of dollars. And last one to mention here, you have the ISP routers for the internet service provider companies. These are the internet backbone, where one of these routers will cost up to $500,000 or even more. Terabits per second. These never go down. Everything is redundant. And the amazing part, they all follow the same principles we're learning today. And the real question is, how do routers know where to send your data? First, a packet arrives at the router from a user on the internal network or from another router. It examines the destination address. It's like reading an address on an envelope. The router checks its routing table. Think of it as a GPS database where you have directly connected networks. The router knows how to reach these because they are directly attached. Or you have static routes where an administrator trained the router how to reach certain destinations, or dynamic routes where other routers told this local router how to reach the destinations. Then it will pick the best path based on multiple criteria, and we'll go into details in future videos. And then finally, it will forward the packet to the next router up to the destination. This happens millions of times per second. Every YouTube video, every email, every web page, all following the same rules. Routers connect different networks. They are the bridges of the digital world. The main functions are routing, network address translation, security, quality of service, and voice over IP. And we have different types from the home routers to the service provider core, and they follow a set of criteria to forward traffic so that your browsing experience on the internet is fast and efficient. In the next video, we're going to discuss layer 2 versus layer 3 switches. If this helped you demystify routers, hit the like button and subscribe for new videos in this series. Thank you for watching, and I'll see you in the next one.